Gamma-ray bursts are the most powerful explosions in the observable universe. In a fraction of a second, a single event releases more energy than our sun will produce across its entire 10 billion year lifetime. They occur when massive stars collapse into black holes at the end of their lives, or when two neutron stars spiral toward each other over millions of years and finally collide. The energy released in either case exceeds the combined light output of all other stars in the observable universe at that moment. What makes gamma-ray bursts uniquely dangerous is not their total energy output, it is their geometry. The energy is not released in all directions equally. It is focused into two narrow jets, concentrated beams of radiation traveling at the speed of light, capable of extending for billions of light years across space. The beam is tight. The fraction of the sky it covers is small. But if Earth lies within the path of one of those jets, the consequences are not survivable. The outer atmosphere would be chemically altered within seconds of the beam's arrival. The ozone layer, which shields the surface from lethal radiation, would be severely depleted or destroyed entirely. Nitrogen in the upper atmosphere would be converted into nitrogen dioxide, a compound that absorbs sunlight and poisons the surface. What follows is prolonged exposure to ultraviolet and gamma radiation at levels incompatible with most complex life. Researchers have proposed that the Ordovician mass extinction, which killed approximately 85% of marine species on Earth around 450 million years ago, may have been triggered by a gamma-ray burst within our galaxy. This has not been confirmed. What is known is that the mechanism is physically plausible, the energy levels are sufficient, and no alternative explanation for that extinction has been definitively established. The geological record shows a rapid ozone collapse consistent with a gamma-ray burst event. Whether that is what happened, no one can say with certainty. Astronomers detect approximately 1 gamma-ray burst per day across the observable universe. Most originate in distant galaxies, far enough away that their jets pose no meaningful threat to Earth. But our galaxy contains the same types of objects that produce them. Massive stars in the final stages of their lives. Neutron star binary systems in the last phases of their inspiral. No gamma-ray burst has been confirmed within the Milky Way in recorded human history, though the galaxy contains objects capable of producing one. The absence of a recorded event does not establish the absence of a threat. Gamma-ray bursts travel at the speed of light. There is no precursor signal that arrives ahead of the event. The first indication that a burst has been aimed at Earth would be the arrival of the burst itself. Detection and impact are simultaneous. There is no mechanism by which the beam could be deflected or outrun. There is no preparation that would be meaningful. The interval between warning and consequence is zero. They are happening constantly throughout the observable universe. Some of them are aimed at regions of space occupied by star systems right now. The universe does not distinguish between inhabited and uninhabited targets. It does not provide warnings. It does not wait.